Hello, everyone. Welcome to another wonderful day of chemistry. So today we're going to go through a broad overview of this chapter, talking about chemical kinetics. So one of the big important things to remember about chemical reactions is there's two interplaying forces: what wants to happen and how quickly we can expect it to happen. And as seen here, these two often can be a little different. So one of the important things to remember is there's plenty of chemical reactions that are thermodynamically favorable, and some of the unfavorable ones, entropy will still let them happen to a certain degree. But just because a reaction is favorable doesn't mean that it will occur quickly. So a good example is looking at the rust of iron. All iron wants to rust. Iron will want to combine with oxygen to make iron oxide, so good old-fashioned rust. And if we take a look at the Gibbs free energy, you'll note that this is very negative. This is a very favorable reaction. This has a fairly large equilibrium constant. And as such, it even happens when you have relatively low pressures of oxygen, which is the only chemical that appears in the equilibrium constant. But it's not exactly like this reaction spontaneously happens overnight. It often occurs fairly slowly. So if I go ahead and take my cast iron pan, which is just straight iron, you'll note that we don't always have this even distribution of rust. It happens in patches and at different rates, which is a major feature here. So what factors control the formation of this rust? And this is something we're going to slowly develop over this course of this next chapter. The first of which is the temperature of the reaction. All reactions go faster at higher temperatures. This is just going to happen for any type of reaction. And you'll note that most of the rust here forms on the bottom of the pan, where it's most likely to be hottest, which will speed up the reaction. Also, reactions tend to occur faster when you have higher concentrations of reagents, which will go ahead and go into play. And the exact ratio of the concentration of reagents can occasionally surprise you and often needs to be determined experimentally. And the final one is the presence of potential catalysts. So these are essentially things that make a reaction go faster. They do this by making it easier for each step of the process to happen. In this case, one of the best catalysts for oxidation is water, as we saw last chapter in electrochemistry. Water is a good intermediate to carry all those electrons and protons to make rust happen. And in this case, we do see that, yes, water was a great catalyst because the rustiest part of the pan is on the bottom, where it had the most contact with any sort of liquid. And one of the big things that we're going to be building up to in this chapter is looking at ways we control the rates of reaction. Because again, even if I have a reaction, sometimes I'm going to want to make it go fairly slowly. In this case, I'm looking at the combustion of sugar. So this is essentially burning sugar. You don't exactly want want all of your sugar to spontaneously catch fire, which according to thermodynamics, it should. Anything made out of carbon, fat, protein, thermodynamics say you should burst into flames any moment now. The only things that prevent spontaneous combustion is kinetics. So in that sense, sometimes having slow kinetics can be a really good thing. However, sometimes you want reactions to proceed quickly. So this same burning of sugar is also a key part of caramelization, which is what makes creme brulee creme brulee. You go ahead and you take a blowtorch and you sear or quickly burn the very top layer of the sugar so it makes this crackly crust. And there's other things we want to happen because the same process of combusting sugar really is metabolism. You don't want to have this reaction go too quickly, otherwise you don't evenly consume sugar. But if it goes too slowly, then, well, you can eat all the sugar you want and it won't do you any good because you'll be starving the entire time. So we're going to be looking throughout this chapter at some of the things that will control the rates of reaction, how we can predict how quickly reactions can occur, and how we can use those three major controls: temperature, concentration of reagents, and catalysts. So next time, we're going to go ahead and dive into some details of what it means to have a reaction rate. Until then, take care.